Okay guys, so today we will talk about the fold bifurcation. Okay, so fold bifurcation, what is it and how? Okay, so fold bifurcation is nothing but bifurcation the bifurcation uh, I would say corresponding corresponding to the presence of, okay, lambda 1, which is eigenvalue, is equal to 0. Okay, is called fold bifurcation. Fold bifurcation. Okay, so the bifurcation corresponding to the presence of lambda 1 is equal to 0. If we have any eigenvalue lambda 1 is equal to 0, then it tells us that okay, we can have fold bifurcation there. Okay, so definitely for the fold bifurcation or for the any bifurcation, we need to have a parameter in the system, and then we can talk about the bifurcation with that parameter. So now uh, we will have the normal form of that fold bifurcation. So normal form. Okay, so normal form means in 1D we will the normal form of the fold bifurcation is actually x square plus alpha, and this is nothing but this is actually function. Okay, so definitely if we want to discuss the stability of this system, so definitely we need to find the equilibrium points, and we can find easily by setting this, and from there we can have x is equal to plus minus square root of minus alpha, and surely alpha is lesser or equal to 0, because if alpha is greater than 0 we will have the complex value which we don't want. And surely we know that clearly if alpha is equal to 0, x is equal to 0 is an equilibrium. Okay, an equilibrium point. Okay, and then definitely our system will be x dot is equal to x square, and if we do the phase plane analysis, suppose this is 0, if my x is positive my x dot is increasing, if my x is negative again my x dot is increasing. So clearly x is equal to 0 is unstable. Okay, now in order to check the stability of other 2 points when alpha is lesser than 0, definitely we will take the derivative of the function. So f of x is 2x, and then surely f of x square root of minus alpha is 2 square root of minus alpha, which is positive, and f of x of square root of minus alpha is lesser than 0, which is stable. Okay, and this is, since it is positive, so this will be unstable. Okay, so now we saw that x is equal to square root of minus alpha with minus sign is stable, and with plus sign it is unstable. So now if we want to have a diagram for this thing, surely if my alpha is lesser than 0, okay, I do have, so definitely suppose if this is my parabola. Okay, so suppose this is my square root of minus alpha, and this is square root of plus alpha. Okay, now as we saw that this is stable, so definitely this should be this sign, this should be this sign. But now we can easily determine this sign. To determine the sign of this thing, what we can do, suppose we want to see, okay, that to the right of this point it is increasing, to the right of this point it is decreasing or increasing, and to the left of this side it is increasing or decreasing. How can we check the sign? So suppose my point is this thing, so this my point is nothing but minus alpha plus epsilon. Okay, and this my point is nothing but this is minus alpha minus epsilon. Now I want to see the sign of x dot. at these 2 points, either it is positive or negative. So suppose I just want to check it for this thing. So definitely I do have x dot is equal to x square, means this is my point. So minus alpha plus epsilon square and plus alpha. Okay, so if we solve it, so this will be minus alpha plus epsilon square plus 2 minus alpha epsilon plus alpha, and surely we can see that this is positive. So this is positive, means it is increasing. And similarly we can see it for the other point as well, and surely we will say that this is negative. So if it is negative, this is decreasing. Okay, so x dot is negative 8 minus square root of minus alpha minus epsilon. So that's how we determine. So we can clearly see that now to the left it is moving away from this. So we can see that the cursor, we can see the cursor, the notation, that it is moving away and it also moving away. But here we can see that it is moving towards this point from the left and also from the right. So this means that this is stable. Clearly we can see that this is stable. Okay, while over here we can see that this is unstable. Okay, but now clearly my goal is to draw the bifurcation diagram. So how to draw the bifurcation diagram? Okay, how to draw the bifurcation diagram. Okay, that is my goal. Okay, so it is easy. What we will do, so to draw the bifurcation diagram, what we will do, so we will assume that my okay, so we will assume that my x-axis is on my x-axis, on my horizontal axis is actually alpha, and my vertical axis is x. Okay, now we have y is equal to, no sorry, x is equal to, okay, so we have nothing, but we have x is equal to square root of minus alpha, and x is equal to square root of minus alpha. Okay, and surely where alpha is lesser than 0. So now over here my alpha is lesser than 0. Okay, over here. So now we know that when x is equal to minus alpha, my system was unstable. So if my system is unstable, I will denote this. So first we want to graph this thing. So surely we know that x is equal to square root of minus alpha. I do have this thing. Okay, so this is nothing but x is equal to minus alpha. Okay, so this is nothing, but this is nothing. This is my x is equal to square root of minus alpha. And why this I draw this line as a dashed line? Because this denotes that it is unstable line. Okay, this represents that okay, at this point my system was unstable. Okay, now for the stable system, x is equal to minus alpha, I surely know that this is actually this thing. Okay, so this denotes that it is a stable. So now what is my bifurcation value? Clearly I can see that my bifurcation value is is 0. Why? Because at this 0 I can see that, okay, so at this 0, okay, over here I can see that bifurcation value. Okay, so this is bifurcation value. At this value I can see that on one side my system is stable and my other side system is unstable. Okay, so we can see that this area is unstable, this path. Okay, and this is stable. So on one side we have stable, and the other side we have unstable. So this means that this is the point from where my system is going from unstable to stable. So this means that this is my bifurcation. So bifurcation is nothing but where your system is going from stable to unstable or unstable to stable. Okay, so this is my bifurcation value. Now we clearly understood that okay, if we have a normal form, one dimensional normal form, then how to discuss the fold bifurcation and how to discuss the stability and how to draw the bifurcation diagram. So that's what we did. But now here's the thing for you guys. Okay, so the thing for you guys is actually the thing for you guys is actually, so suppose now what now now what if we have system x dot is actually x square minus alpha, then how to discuss the stability and how to draw the bifurcation diagram. That's what now we need to understand. Okay, so sorry, what if my system is this thing? Okay, alpha remains alpha minus x square, then how to discuss the stability and how to plot the bifurcation. I would say this is completely opposite of what we did. Okay, so you can think about it and you can do the same analysis for this one. You can see which point is unstable, which point is stable, and how to draw the bifurcation diagram. Okay, so I think that's it for today.